Hi, this is Sri Ragramadagu. In the last video, we learned about decision trees. Uh, it's working, evaluating splits, and when to stop splits, using entropy, variance, uh, split scores, node score, and also using Gini coefficient. In this video, we'll look at some of the advantages and disadvantages of decision trees, and then we'll look at this example where I use iris dataset uh, to implement decision trees. So first we'll see what are the advantages of decision tree. So it is easy to understand and often very accurate using decision trees. Uh, it learns non-linear relationships, maps nicely to set of business rules, makes no prior assumptions about the data, and it's able to process both numerical and categorical data. And some of the disadvantages of decision trees are uh, decision trees algorithm can be unstable. Different trees on slightly different data. How to, and trees created can be very deep and complex. Ability to model global linear relationships. These are some of the disadvantages of decision trees. So now let's look at the implementation part. So first, I have imported all the libraries that are required. I have imported pandas, NumPy, and for the dataset, I'm currently using Iris dataset. So for that, I'm importing it from sklearn.datasets. And to implement decision tree, I have imported decision tree classifier from sklearn.tree, and to split the data into training set and testing set. So I have imported it from sklearn.model selection. So let's look at first the iris dataset. I have just loaded it into a variable called data. So this is my object here. So let's try run this. So we can see the classes to predict: Setosa, Versicolor, and Virginica. These are the classes of the target names. So let's first extract the data attributes and the target values, all the class labels. I'll just load that to y variable, and the rest data I'll load it to x variable. So the number of examples in the data, it's 150. Now I'll split the data into test and train sets. Here I used random state as 42, so that whenever so there is no random state. Random state is just like a seed value. So when if we tend to train the data again using the same random set, the same we can see the same output. So now I'll import the decision tree classifier from the sklearn library, which I already did here, and then here I'll use the criteria as entropy. Now I'll train the decision tree classifier. So we can see the decision tree classifier here. Class weight none, criterion entropy. So we are using entropy, and we didn't give the inputs like max step, max features, max leaf nodes, and all. So basically, if the data is very small or the data is very large, if we have certain conditions, if we set certain conditions like max depth and max features, so that to avoid overfitting. So we can adjust these variables to avoid overfitting and underfitting. So if the max depth is very small, then obviously it's going to underfit. At the same time, if max depth is too large, then it's going to overfit. Now let me predict the variables. Okay. So in order to know the accuracy of model, I'm going to import accuracy score from sklearn.metrics library. So let's run this. We can see the accuracy score on the train data is 1.0 and accuracy score on the test data is 0.963. I can even add the values, like here I just added min sample split is 50, so I can even add the other variables that we have seen here, like max depth and all. So I just added one variable here, and let's see how this how the accuracy changes. Here we can see that the accuracy score on the train data is 0.94, whereas in the previous case the accuracy score on the train data is 1, that is 100%, and the accuracy on the test data is 0.936, and the accuracy here is the same. So even making the minimum sample split as 50 on, we are reaching the same accuracy score on the test data. So this is the implementation of decision tree. Thank you.